Welcome to this lesson on finding the zeros. So this is kind of building off of the previous lessons we've done about factoring. And in fact, finding the zeros is one of the reasons why we factor. There are many other reasons. However, finding the zeros is one of them. So what does it mean to find the zeros of a graph? Well, if you have a graph, let's say it looks like this. It's a cool little M shape. M for magnificent. That's it, magnificent. So the zeros are the points at which the y value is 0. Or another way you can talk about that is it's the x-intercept. So if this is your x-axis and this is your y-axis, it's the points at which it crosses the x-axis. So those points are at -5, -2, +2, and +7. So I'm just going to list them out up here. So our zeros are -5, -2, 2, and 7. So the fact that we can see them so easily in the graph makes it really helpful, especially in later on contexts where it may be not so easy to do it from the equation form. But let's stick with this idea of looking at the zeros in the graph, and go ahead and take a second, see if you can find the zeros of this graph right here. Great. Well, you should have noticed that they were at -4 and 6, so those are the two zeros. So what if we didn't have a graph, or they just gave us an equation? How can we see the zeros in an equation? Well, we could, in fact, use a graph to identify what the zeros are. And let's do that real quick. Let's look to see, let's graph x minus 3 and x plus 4 and see what we get. So we have our calculator right here. Let's go ahead and put in x minus 3 and x plus 4. X minus 3 and x plus 4. Let's go ahead and graph it. Great. Well, we can see that our zeros are going to be about 1, 2, 3, 4, -4, and +3. So our two zeros are at -4 and +3. So let's go ahead and sketch the drawing over here. So we have, hold on a sec. So here we have that our zeros are at -4 and +3. So x equals -4 and +3 are our two zeros. Well, let's see if we can make sense of these two things just by looking at the equation above. So if one of the zeros is at x equals -4, if I were to plug that into the equation above, I get y equals -4 minus 3 times -4 plus 4. And let's see what happens with this. So we have y equals -4 minus 3 is -7, and then -4 plus 4 is 0. And as we know, 0 times anything is going to be 0, so therefore that means y must be equal to 0. So when x equals -4, y is 0, which makes sense, right? This point right here is the point -4, 0. The y value is 0 there. And so we would assume that this should be true with 3, meaning that the point is 3, 0, so we should get 3 at 0 out when we plug in 3. So let me erase some of this stuff. So erase some of this. Let's go ahead and plug in 3 now and see what happens. And watch for what's happening and see if you can identify exactly why it's happening just like it is. Okay, so if I plug in a 3, we get y equals 3 minus 3, and then 3 plus 4. And if you notice, on the left side, the 3 minus 3 becomes 0, so we get y equals 0 times by 7. And the magic is with the 0. In making one of these two things, either the x minus 3 or the x plus 4, making one of those becomes 0. And when one of those is 0, it's going to cause the other one to end up being multiplied by 0. So therefore y must be equal to 0. Let's say that better. Y is equal to 0 when x equals 3. So it did work out just as we thought. Well, this is pretty powerful. It means that if I have the equation in factored form, which is what this is, then I can immediately see what the roots are going to be, or the zeros. Meaning, if I can make this right here 0, then that will cause the whole thing to be 0. Or if I can make this other part to be 0, then that will make the whole thing 0 as well. So, let's go ahead and look at another example, see if we can make more sense of it. So say we start out with y equals x squared plus 2x minus 3. Well, this one I can't really see my zeros in it because it's not in factored form. And this is why factoring can become helpful. Remember that if I didn't know how to factor, I could always look at the graph. And I think we will to use that to check our answer. But let's try factoring this. So I'm going to make a list of things that multiply to give us 3 and see which one will work out for us. So it's pretty simple. I mean, 1 times 3 and 3 times 1. It's pretty much our only options on this. So if I made the 1 a negative, then it would work out so that I could write it like this. Y equals x minus 1 times x plus 3. Remember that this has to add to be 2 and multiply to be negative 3. Okay? And if you want to go ahead and factor or FOIL that out, you'll see that you do get the thing above. Well, now that it's in factored form, I can look at each of the two sides, namely this one, and in order to make that 0, x will have to be equal to 1. And then in order to make the right side to be 0, x must be equal to negative 3. And so these are my two zeros. Let's go ahead and check it with the graph. So we have x squared plus 2x minus 3. So we go ahead and graph that. So it looks like I made a mistake here because you see that I don't have my zeros where I anticipated they'd be. I'm guessing I made a mistake with the equation. Let's go back and check. So I have x squared. Oh, there we go. It should be 2x. So second insert, 2x minus 3. So like the more you know about mathematics, the more you can check your answers and make sure you're doing it right. I'm able to check it multiple ways. Let's go back to the graph. And if you notice, my zeros are exactly where I thought they'd be, where x equals 1 and x equals negative 3. Goes left, 1, 2, 3. Awesome. So I got my two zeros located, x equals 1, x equals negative 3 on the graph, and that confirms what I found algebraically, and those are indeed the correct answers. So x equals 1 and x equals negative 3. Let's look at a couple more examples, and then we'll be done. So what are the zeros of this? Go ahead and take a second and see if you can figure it out. If you need to pause it to take a little more time, that's fine. If you want to try graphing it and checking your answer in just a sec, that'd be great. So what we need to do is look at the first part. So what value of x can I stick in that box in order to get 0 out? Well, when x equals 3. If I put 3 minus 3, that'll give me 0. So x equals 3 must be the first root, or the first 0. And then in the second one, the second parentheses, what can I put in here that'll give me 0? Well, 6. If I put 6 in for the x, 6 minus 6 will give you 0. So that's going to give us our second 0. Excellent. And if you want to go ahead and graph those in your calculator, you'll find that those are the zeros. So this one's written a little bit differently. Instead of saying y equals and says find the 0, it says 0 equals. Well, that's just the same thing. We're supposed to solve for 0. Instead of having x values, we have t values, but that doesn't matter because x is just a letter, a variable. We can use any one that we want. So how would I find the zeros of this one? Go ahead and take a second and see if you can figure out for yourself. Okay, well if you want more time, go ahead and pause it and see if you can work it out before I do it. So I'm going to, first off, that's not in factored form, so I can't just see the zeros directly from the equation yet. So let's try and turn it into factored form. So this one has a 5 out in front, so it's a little more difficult to factor, but it's still doable. So we're going to do 5 times negative 18. That's going to give us negative 90. And let's list our factors of negative 90 in order to get, so that we can find one that adds to be 9. Well, 1 times 90 should always be the first one we do. 2 times 45. 3 times 30. I'm not sure if 4 divides 90 or not. I don't think so. $90 divided by 5 gives us 18. So far I'm not seeing anything that gives us a 9 out. So 90 divided by 6 gives us 15. Well, that looks pretty promising, 6 and 15, because if I subtract them from each other I end up getting 9. So I want to make sure that 6 is going to be negative because I want to get a positive 9 out of it. So now I can factor using the window way, if you remember that from class. So I go ahead and put the 5t squared right here, and then I put the negative 18 down here. Doesn't matter which place I put the negative 6t and the 15t. Okay, so outside of the 5t squared, one of them is going to have to be a 5t, and then it will just be a t. Hopefully I chose wisely. 5t times what gives me 15? Well, 3. T times what will give me negative 6t? Negative 6. So that's 5t squared. Negative 6 times 3 is negative 18. So now I just use the outsides over here, and that's my new factored form. T plus 3 times 5t minus 6. Great, so this is my new factored form. That's equal to 0. So what values will give me 0 out? Well, I need to make this one equal to 0. So that's going to give me t is equal to negative 3. If I put negative 3 in for t, that gives me out 0. The harder one is maybe this right side, 5t minus 6. I need 5t minus 6 to be equal to 0. Well, if I write it like this, it helps me out a little bit more because I can see it as a two-step equation to solve. If I add 6 to both sides, 6 equals 5t, divide both sides by 5. So t is going to be equal to 6 over 5. Or if you put that into your calculator, it's about 1.2. So those are my two t values, 1.2 and negative 3. And if you look at your calculator, those are the two that you will find as your zeros. Thanks for watching.